Okay, welcome to lesson 5 of the motion topic. I'd like you to start by pausing the video to complete the quiz. And pause it again to check and correct your answers. Okay, so far in this topic we've looked at speed. Then we looked at being able to plot speed on a distance time graph. We then had a look at the speed of particles and the speed of waves. Then we looked at acceleration. Acceleration is the increasing of someone's speed or an object's speed. Today we're going to look at how we might plot acceleration on a speed time graph. So that's what we're going to look at today. Okay, acceleration is a way to describe how quickly an object can increase their speed. Let's have a couple of examples. So these two cars will be able to increase their speed at different rates. That means that they will be able to do it over a different amount of time. The red car will increase their speed much quicker than the blue car will. So the red car will go from 0 to 60 in probably about 3 seconds, whereas the blue car will go from 0 to 60 in probably about 10 seconds. So the red car has a greater acceleration. The blue car has a lower acceleration. Let's have a look at an example then. A car has an acceleration of 2 meters per second per second. Now what that actually means is a car accelerates by 2 meters per second every second. A car accelerates by 2 meters per second every second. So a car increases their speed by 2 meters per second every second. Now let's assume that this car at time 0 starts at 0 meters per second. If it increases its speed by 2 meters per second every second, then after 1 second it's going to be going at 2 meters per second. If it increases its speed by another 2 meters per second every second, then after 2 seconds it's going to be going at 4 meters per second. And after 3 seconds, it's going to be going at 6 meters per second. And after 4 seconds, it's going to be going at 8 meters per second. After 5 seconds, it's going to be going at 10 meters per second. And after 6 seconds, it's going to be going at 12 meters per second. So after every second, the car increases its speed by 2 meters per second. And that's what an acceleration of 2 meters per second squared, or 2 meters per second means. So what we can do is we can use those numbers and we can plot them on a speed time graph. So time is in seconds and speed is in meters per second. And this graph is going to show us how the speed has increased. So we said that at 0 time, the speed would be 0 meters per second. After 1 second, we said the speed would be 2 meters per second. After 2 seconds, it would be 4 meters per second. After 3 seconds, 6 meters per second. After 4 seconds, 8 meters per second. After 5 seconds, it would be 10 meters per second. And after 6 seconds, it would be 12 meters per second. So this object has gone from 0 meters per second all the way up to 12 meters per second in a time of 6 seconds in total. And what I can do is replace all of those crosses with a straight line, with a line of best fit. And this shows me the acceleration of an object. Okay, let's have a look at another example. A motorbike has an acceleration of 3 meters per second squared. Now that means that a motorbike increases its speed by 3 meters per second every second. A motorbike accelerates by 3 meters per second every second. So if we assume it starts at 0 seconds, then it's going to have got a speed of 0 meters per second. After 1 second, it's going to have a speed of 3 meters per second. After 2 seconds, it's going to have increased its speed by another 3 meters per second. So it's going to have a speed of 6 meters per second. After 3 seconds, it's going to have a speed of 9 meters per second. After 4 seconds, it's going to have a speed of 12 meters per second. After 5 seconds, it's going to have a speed of 15 meters per second. And after 6 seconds, it's going to have a speed of 18 meters per second. And we can plot this data on our graph as well. So at 0 seconds, the speed was 0 meters per second. After 1 second, the speed had gone to 3 meters per second. After 2 seconds, it was 6 meters per second. After 3 seconds, it was 9 meters per second. After 4 seconds, it was 12 meters per second. After 5 seconds, it was 15 meters per second. And after 6 seconds, it was 18 meters per second, but that doesn't quite fit onto my graph. And so again, we can use a straight line to represent the acceleration. This tells me how much the speed has increased by on the y-axis here, in how much time on the x-axis here. And that tells me the acceleration of that object. If we compare both of those accelerations, this one down here was 2 meters per second squared, and the blue line was 3 meters per second squared. We can see that a steeper line represents a larger acceleration on a speed time graph. Pause the video to answer these questions. And pause the video to check and correct your answers. Okay, we're now going to have a look at a journey described on a speed time graph. So what I do is I break up a journey like this into sections, and then I talk about the sections individually. So this is section 1 here, this is section 2, and this is section 3. So section 1 shows the object moving from 0 meters per second down here up to 9 meters per second up here. And the object does this over 4 seconds. This line here shows me that the car or the object is accelerating. The object is getting faster and faster and faster. The speed is increasing. So at section 1, the object is accelerating. Let's have a look at section 2. So this shows that the car or the object is at 9 meters per second for all of this time. It's at 9 meters per second from 4 seconds until 11 seconds. So for 7 seconds, the car is just travelling at 9 meters per second and it's not changing. So this tells me, this section 2 tells me that the object is moving at a constant speed. Which means the speed is not changing, it's always the same for that section. And so a flat line like this on a speed time graph shows the object travelling at a constant speed. Now section 3, the object starts at 9 meters per second and ends up at about 5 meters per second, and it does this, it slows down over a period of about 8 seconds. This shows me deceleration. the car has gone from 9 meters per second to 5 meters per second, and it's done that over about 8 seconds. That shows the car slowing down, which in physics we call deceleration. I'd like you to pause the video and have a go at describing the journeys on these speed time graphs. Now pause the video and check that you got the description of the journey correct. Next, I would like you to divide your page into 4 like I've done. And I'd like you to pause the video and draw a graph, a speed time graph, for each of these statements. Don't worry about the numbers, just try and get the shape of the graph correct. Now just pause the video to check and correct that you got the shape correct. Don't worry if you didn't get the right scale, so if you did one bit longer than I did, don't worry about that. Just concentrate on getting the shape correct. Okay, so what we can do, as well as just describe the journey, is we can also calculate the acceleration at each point on this graph, and I'll show you how. So, the equation for calculating the acceleration is that acceleration is equal to the change in speed divided by the change in time. I covered this on my last video. And so for section 1 here, the change in speed is from 0 to 12. And the way we calculate the speed is we do the final speed take away the initial speed. So the final speed is 12 meters per second and the first speed was 0. So the change in speed is 12 meters per second. The change in time, the time it took for this to happen, well, it started at 0 time and it reached 12 meters per second at 4 seconds. So the change in time is 4 seconds. And so we want to find the acceleration. So acceleration is the change in speed divided by the change in time. In this case, that's going to be 12 divided by 4. And so my acceleration is 3 meters per second squared. Meters per second squared. We can write that as 3 meters per second squared. Okay, section 2, up here. Well, I've told you that if it's a flat line on a speed time graph, speed time, then there is no acceleration because the object is travelling at a constant speed. So the acceleration in this case is 0 meters per second squared. We know that because it's a flat line and therefore it's going at a constant speed, which in this case is 12 meters per second. And finally, let's have a look at section 3 over here. So we're going to have a look at calculating this deceleration, the slowing down, but I'm actually going to call it an acceleration. What we're going to end up with is a negative acceleration, and that tells me that it's slowing down or deceleration. So the change in speed, well, the final speed is 9 meters per second and the initial speed is 12 meters per second. So 9 take away 12 gives me a negative number, minus 3 meters per second. It's changed from 9 meters per second, from 12 meters per second to 9 meters per second. And this minus shows that it's slowing down. The time that takes is from 11 seconds to 17 seconds, so 6 seconds. And we're going to find the acceleration. So acceleration is the change in speed divided by the change in time. So acceleration is -3 divided by 6. And that gives me an acceleration of minus 0.5 meters per second squared. Now this minus tells me that it's slowing down. It's not speeding up, it's not actually accelerating, it's decelerating. But we can call that a negative acceleration. You're now going to have a go at the worksheet Speed time graphs to practice calculating the acceleration of different journeys.